Welcome to testing episode 1. Possibly the only episode. Let's get to it. All we're doing is we're testing this through. You've probably seen the previous episode. I woke up early. Thought, ooh, I've got a happy joy toy to play with. And yes, I have. Yes, I have. Look at this. A happy joy toy. Test. Awesome. How good is that? Well, not very good at all, really, but... Right, so... When it comes to testing, we've really got to test, well, the whole thing, all at once, which is not how I'd use it in a program. I better warn you about that straight off. This is an impractical test. Because all I'm going to do is include absolutely everything in the main file and just test it all in the test area. There you go, absolutely everything at once. So hash include, we're going to be doing that a bit. So what we're going to need, let's start with that API bit. Yeah, heart of the API is the data loader. Data loader.h. And of course we spent a lot of time there on the model loaders, the OBJ loader. So let's pop one of those on. Hash include. Doesn't really matter which order I do all this lot in because it's just a straight test. Let's see, models. And we popped into a model loaders. Yeah, I know I'm not going to get IntelliSense on this, don't you worry about it. Microsoft was never this clever. OBJ, and we just called it loader. So that was to load up our models. .h. Close. Yes, I am using angle brackets because this is all in our library. Just as these are all in C++ library, these are in our library. So there we go. Let's also include some entities, shall we? Camera, for instance. Let's include entities, yeah. Just so right, memory, entities and camera.h. That's where it is, that's where it resides. Right, 1, 2, 3, 4, that'll do. Well, let's get started with that. So we've done the window. That was okay. Window set background, yeah, go on, we'll keep that. I've changed the number slightly, and I've also set the window swap to 1, so it's with the refresh rate, so it doesn't start my fan up. If you put it to 0, anybody who's seen the previous episode knows what I'm talking about, then my fan starts up and starts cooling down a graphics card as it's pumping out lots and lots of nothing. So I don't really want that. Let's start here. What can we do to start off with? We'll need that data loader. That's a given. So we've got API ::, data loader. There it is. And I'm just going to call it something really unique like loader. Notice I am not going to be bothering with pointers at this stage. I'm just going to be sticking them down as straight names. I don't care. The system works either way. This is a test. I don't care. If I run out of chip memory, which is 2 megabytes by the way, the whole of this program is only going to be about, what, 256k? No, it's not going to happen. All the graphics are going straight to the graphics card. There's no chip memory being used. We can hold all of this right next to our chip and be happy joy. Don't you worry. Model loaders. If anybody was worrying about it. Model loaders. There we go. Go on. What did we have? An OBJ loader, was it? Oh yes, so we did. There we go. And what should we call this? Let's call it something original like OBJ loader. Because we can. You can call these anything, by the way. Doesn't really matter. Let's have an entity. You'll find out why I'm doing it in this order now. Entities. Colon. Camera. And guess what we're going to call this one? You guessed it. Bet you could have filled this in. Not going to do anything else there for now. Let's have a look. What else do we have here? Just the camera. So, terminal. Run build task. Yeah. Debug. Start. Yeah. No problems there. So we have a loader, an OBJ loader, and a camera. What can we do with that, do you think? I'm going to do lots with it. Remember, there's going to be at least a few typos and at least one mistake or two mistakes made in the whole of the programming that we've done. So don't you worry about it. This is not going to be a straightforward roll with it. No, it's not going to be a camera roll. Let's try the render engine. Oh yeah, baby. We've done those. Those are okay. So hash include. We put it into the render engine. GINE. And we called it what? Let's have a look now. I'm on the fly now. So I'll keep my source open. Render engine. Master renderer. Yeah, that's the only bit we're going to need out of there. As you remember from the programming of it, it creates everything else for us. Cute. So let's put one in. Let's make one. How do we make a master renderer? Can anybody remember? We can't remember. So we are going to use master renderer. It needs a window and it needs a camera. That's why I wanted the camera, by the way. So let's do that. So we are going to do that. It's going to be, remember I put using namespace Amber so I don't have to keep putting Amber : in front of all of these. Otherwise you would have to. And that spoils some of the joy, I think, when doing this kind of thing. So render engine, : and it's master renderer. What should we call this? Let's call it master renderer. I love these names. And we'll pop the window. It asks for the window and the camera. So we'll pop those two in. There we go. Done. So let's try running that as a build. I'm going to upsize this now. Yep, nothing to be done, that's fine. Debug. Start debugging. Oh, bingo. What happened here? Unable to load shader. Well, yeah. Alright, let me just keep that window open. Here we go. Unable to load the shader at ... source. Why? That's where we put it in the API, didn't we? Under GLSL. Yes, we did. Let's go back to our program. Let's just see where we are. And if our program will tell me. Is it in tasks.json by any chance? No, it's not. Is it in launch? Current working directory is test. So no, we didn't put it in test source API GLSL. We put it in AmberSL. source API GLSL, didn't we? Yeah, that's never going to work. So here we go. Let's get that sorted, shall we? Who is messed up then? So it's the shader loaders. Shader loaders. Okay, that's messing us up. Get back to main. And who is our guilty party? OpenGL Shader Foundation. Oh, here it is. So it should really be /AmberSL. Same again here. This is why I wanted to do it this way. So /amber. You have to match up what you are doing, because I will always, and I know that I will always have my AmberSL in a folder called AmberSL, and it will always be next to whatever I am programming. As a folder, the two folders will always be side by side under a working directory, because that's how I program. So I am quite happy to do that, and it will never break. He says. Bet it will. Right, so we've changed that. It means we have to now do that. Yeah, I don't know. How many mistakes can I make? You may think. Well, we'll see how many we can get through. Run the build task. AmberSL updates. Magic. Take you back to test. You see, there wasn't a build problem. The actual code isn't wrong, but what we'd done, it was wrong. The information within the code was wrong. So save that out. Go away. Terminal, build run task. Test is updated. Crossing your fingers. Boom. Error. GL compile. Oh, it's loaded them now, has it? I bet it has. But we have an error on our V shaders, which is the first one, not the second one. Of course, the link will fail if there's an error. So compile shader failed. 027 error normal undeclared. That's all I need to know. Again, I can keep that open if I wish. I don't really wish to, because that doesn't matter to me. So that is actually a few errors. Just make sure I haven't got any more there. Nope, that's okay. That will be a number of errors because we have duplicated our shaders. So let's go to our shaders now. It's in AmberSL source API. GLSL basic shader. We didn't use it, did we? Nah. So let's go on to our static shader. On that line, in normal, normal's okay. It's undeclared. Oh, yeah. Yeah, it's a typo. It's a typo. It's NORMAL. I can't believe you lot let me get away with that. So that's in the shader there. It'll be in the terrain shader as well, because we did exactly the same. So we can save those two out. And now if we run our program, remember the shaders are stored outside of our program, so we don't need to recompile. Debug. Start. Clean. There you go. All errors gone. Nice. We now have a master renderer. Oh, can you feel that tingling yet? Can you feel it? There we go. Shader foundation's done. Main, back to main. Where are we? We're on render engine. So, after render engine, what do we want to do? What we want to do is load the model and texture. So let's load a model and texture. Now, we went out of our way to make some, didn't we? So, let's just close all this off again. API, source, AmberSL. Get out of it. You're done. We have resource. OBJ textures. So, OBJ textures. Nice. How do we do this? We're going to need a model base and a model textured. Yeah, we are. So here, just a couple of spaces. Let's do the next lot. Include. That will be models / model base .h and hash include. And it's models. If you notice, we haven't used any C++ yet. And it will be model textured. And that's a .h. I'm hoping I've got those right. Squiggly, squiggly, squiggly. Go. Thank you. So that's in models. Lovely. Here we go. Let's do it. Let's do it. Let's do it. So, models. Model base, please. I want first of all. Let's call this our head model. Let's just do a head model because this is no point to this. I'm going to call it in via obj loader because we need to load it. So obj loader. Then we are going to load object model. And I know it's called head because I can see it from here. It's called head.obj. So head. Do I need any other information? Yeah, we needed to pass over the loader, didn't we? So let's just pop in loader. There we go. That's why I named it the same. Just make it look easy when it came up and prompted me. So models model textured now. Let's load up the texture. We'll call it head model textured. So that's head model textured. Why not? Call it anything you want. You don't have to call it these silly names I'm inventing off the top of my head. Literally. Little joke there. Wow. So it's the head model. What do we need to do? Just load it up, please. Loader. And that's going to be .load. Texture, please. Thank you. And what's the name of the texture? I'm going to use blue. Yeah, blue. I want the blue head. There you go. Now, if you remember, you go back here, it says file name. It doesn't say file path, it says file name. Just like, I haven't showed you for the shaders, because it's all wrapped in the master shader now. Bless. It's even easier, isn't it? You don't even have to tell it where the shaders are, it picks them up automatically in there. So you never even see any of the renderer. What a shame. Shall we try it? Terminal. Run build task. It builds. Start debugging. Well, we've got the object file and we've loaded it. Now if I close the window, it'll come up with a texture, yeah. Because there's a return error on texture loader. So texture loader hasn't got a return value at the end. It's got a return value at the beginning, but not at the end. Silly me. Texture loaded. So, just thinking where that might be. So it was somewhere in the loader, wasn't it? Let's just have a quick look at it, shall we? It's in the API. So let's go over there, API it, texture loader, texture loaded, yeah. What's it missing? It's missing that \n. That's all it's missing. Is that really worth it? Yes, it is really worth it. Yep, absolutely 100%. Let's rebuild it. If you're going to get it right, this is the time to do it. SL. That's okay. Save that out. AmberSL, please build. Ooh, thought about it, didn't it? Must be something else going on my computer called uploading to YouTube. So back to test. Save. Terminal. Run build task. And let's try debugging again. There we go. It now prints up properly and returns to the next line. Texture loaded. So we've loaded a head and a blue, which is what we wanted. Fantastic. We're doing well, aren't we? We're actually loading things. Woo! Well, let's go back to our main. Bless. So, what do we want to do next? We want to alter our textures. Because if you remember, we added some variables. So alter textures in case they're metallic or not. Texture variables. This isn't as simple as it should be, and it's something I could have done better, I think. So normally I wouldn't bother, I'd just go with whatever for the tests. But because it's here, I'm going to use this as a manual to show me how these things can be done. So I can refer back to this later. So under model textures, we need texture. So that will be where? No. Go back up here. API under models, model texture, texture. Right, thank you. So what we're going to do now, I'll keep this all with the same actually. Include, because it's all part of the same area. Yes, I missed a \n. Okay, and I've misspelt normal once. Not bad really for the amount of stuff we put in. So it's models, and it's going to be model textures. And I just want texture. Texture.h please. I just want to access the texture to modify it. Nothing else, that's just to modify it. This is really optional. But I'm doing it anyway, because we can. Yes, always do it because you can. If you mess it up because you can. And then fix it because you can. So model textures, we now have texture, of course. And this will be head model textured. Let's call this head texture. Texture, yeah. So head texture equals head model texture. We just loaded it up there. Texture dot get texture GL string. Oh, get lost. I hate it when it does this to me. It's because it's in a different program. It doesn't like going through to other programs. Let's have a look at this. Head model textured is a D. Get texture was the function. And that's it. That's better. So what we're going to do there is we're going to get the head texture. Now what can we do with our head texture? We can do quite a bit. Head texture dot set shine damper. Was it? Yeah. Set to shine damper. Let's set that to 16 so we get at least a bit of reflections. A bit more metallic. It's about middle of the road between matte and metallic, I suppose. 32 would definitely start on the metallic. This is the beginning of the metallic range anyway at 16. So we'll take that. Again, the other values are 2, 4, 8, 16, 32, 64. Yep, they're all powers. All in powers of 2. So that's your shine damper. And of course, head texture also had another one, didn't it? Because we just saw that it did. And we're going to set reflectivity, the reflections. I'm not going to set that too high because I don't want too much reflectivity. Only half the light can be reflected back maximum. There we go. 50%. That's a percentage. Straight percentage, that's all it is. Terminal. Build. Okay. Debug. Start. Now it's definitely unimpressive now. Good. I like it when it's unimpressive. Now we're getting to see things are right. Yeah. Surprising. Let's create the entity. And we can then place that into the scene. Yeah, I can do that. What we'll need though is entity for that, to create an entity. Alright, here comes some nice tests. So include, and it's just entities, and that's /entity. Let's see, I'm still doing it. .h. At least I know I'm doing it. So let's make one. Shall we call it head? Why not? Or the head? No, we better not. This is going to get a bit weird and wonderful if I do that. It's entities, come on. And it's entity. And we're going to call it head. We're going to give it the full textured model. So that's head textured. Head model textured. Sorry, that one. Head model textured, and we're going to call. We need a position, don't we? It's coming up on the screen for us now. So yeah. So giving it the model textured. Position is a vec3. Okay, let's make one. Vec3. Why not? We've got it. Let's place it at X, Y, Z. So X, don't want it across the screen, anything. Y, don't want it up in the air or down below the ground. And I want it -3. 3 meters in front of us. Remember, it's a 2 meter square cube, if I remember right, or well, off-shaped cube. So I want it in front of us. That's our position. What else do we need? Rotation X. Oh, that's an easy one. Don't want any. Y and Z. I don't want any rotations. Thank you. And scale 1. Don't want it to grow or shrink. Done. We've got an entity. Okay. Will that build? Hope not. It will. It will. And it'll close. Unexpectedly exit code 1. Interesting. I think that's because we're not closing down properly now. We've gone too far with tests. Okay, let's get everything else in then. Before we rebuild. I want to get a clean close. And at the moment there's nothing closing this down. There's nothing cleaning it up after we're trying to close down. If I go to terminal, run build task, there's nothing to be done. But if I have a look at that debug console, thread debugging using libthread db enabled using host libthread. So we've got a main process going here and we're not closing it. Well, it's normally there, but we're not closing it actually properly ourselves. Yeah. So we need to do that. And the only way we can do that is by putting the full program in. To be honest with you at this point, because we did it that way, so everything would close down for us. Well, we're trying to close things down that we haven't even made yet. You know, it's stuff like that is going to happen in the background that we will have no control over, because this is our core build, everything should be used together, if you see what I mean. So we're created an entity, which I spelt wrong again, and we'll place it into the scene. So now let's position the light. What light? There isn't one. There will be in a second. Light, please. I bet we call it light as well, don't we, eh? You can see what's coming up already. Muppet, you're on my arm. So, let's include all the entities that we haven't included yet. So that's light. L-I-G-H-T. What else haven't we included? Terrain. Gosh, I've forgotten all about that. Does help. Yeah, I'm going to put the terrain up, don't you worry. Terrain. Anything else we haven't included? Nope. That's it. That's all we've got left. Yeah, that's all there is. Silly, isn't it? All of those functions devolve into these commands, and none of these are C++ commands. These are just entry points into functions that are worded in a way that we can understand them as humans a lot better than we could understand all of that language like OpenGL, GLSL. Instead of learning the languages OpenGL, GLSL and C++, all we now need to learn as a language are these. This is my manual for 3D. Let's make a light. Entities, colon, yeah, we've now got light. Let's call it light. Open brackets. What do we need for this one? A vec3 for position. That's a def. We will put it at 0, 0, f, x across nil. We could put it across a bit. Yeah, we'll go across 1. So it's coming from our right. Y up in the air. The object is 0.3 away. Sorry, the object is 3 meters away. So I want this 3 meters into the air. There we go. And the Z file straight above us, please. Sorry, Z is backwards and forwards. So yeah, straight above us, please. So left and right, 1 to the right. 3 up, 0 in front or behind. That's where we're going to put that alignment. What else do we need? Color, vec3. Okay, vec3. This is also the luminosity, or how bright the light is. So I always start my lights off at 0.8 so I can have brighter lights if I need them. The sun should always be the brightest light, obviously. But I find, no, not necessarily. If you've got a light closer on a dark, dull, shady day, it isn't it? So, yeah, things to think about. That's a vec3. That'll do nicely. Bye. Done. Does that while? Calm down. Thank you. Right, so we position the light. What else have we got left to do? Just create the terrain, I think. Create a terrain. Entities, colon, we have a terrain. Let's call it, let's think now, terrain, maybe? Why not? And where we're going to put that? It's at grid 0 in our atlas, comma 0. So that's where it is in our atlas. We haven't got one, because I haven't done one. It needs a loader, doesn't it? So it can have 1. What else does it need? A texture. Grass? Did we? Oh, we had a terrain texture, didn't we? Whoa, sorry, Muppet. I'm banging your head, aren't I? Silly me. Terrain. PNG. Yeah, we've got one. We'll have to load it, though. So it's going to be a loader dot load texture, and that's going to be terrain texture. I'll do actually. Yep, that's the last one. There we go. Get rid of that clear screen now. Thank God, that was bugging me. That clear screen, by the way, is already included for us within the master renderer, so we don't need that. So our whole program now, that's the setup. Our whole program now is a while loop that just goes around and around and around until we want to close the window. So let's start with the camera. What can we do with the camera? Well, we can move it, can't we? Window. We can move it within our, well, as part of the window. So that's okay. We then need to register the terrain first. I know we did it last, but it goes in first. Well, for this version anyway. For this draw call. Just to make sure it's only for one draw at a time, one draw call. Yeah. And that will come under master. This is where it gets clever, because we're going to dot process terrain. And then all we're going to do is send in terrain. That's all it needs. So now we can register all entities, because there can be multiple entities, of course. You don't just need to stop with one. To be drawn. No, sorry. Yeah, to be drawn this call. Remember, only one call. Only one draw call. And you can guess what this now is. Master renderer dot process entity, and all we're going to send into that is our entity, the head. That's that done. And we've got our camera, so we better set. Why have I stopped putting spaces in? I wish I'd do things in a instead of randomly. Just, you know, did them all the same. So what are we setting here? Got to word this right. Set which light and camera to use. Then, yeah, and make the draw call. Put in those capitals there because it really does matter. That there is only one draw call ever, because we've made a master renderer so we could do it. So it's master renderer dot renderer, and it's open brackets, and what did we ask for? Light camera. Yeah, that'll do it. Thank you. So that's light camera action, and the last line is just going to be. I've done it again, haven't I? Ah, dear. The last line is just going to be update the window to display the new scene. What we've just drawn, in fact. So window update. Are you happy? Are you happy, happy, joy, joy? Shall we save it out? Yeah. Let's see what we get. Nothing there. And this time I'm going to leave the console open. Bum 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 bum. Resource texture terrain.png. Oh. We've got something. We've got a square by the looks of it. Well, that's interesting, isn't it? Okay. Is it coming out of it properly? I see no warnings now. Yay, it's a proper process number. Yay, it's coming out of it properly. Yay, we can get rid of you lot now. Thank you. That's all I needed to know. We've got it up and running. Fine. So, not part of the program. So, for testing, let's do something. Let's take the head and let's increase rotation. Position would be very good because it'd go off the screen, wouldn't it? But rotation would stay on the screen. So let's go for 0.1 degrees. Yeah, that little. So that'll be 6 degrees per second. If I can ever get it right. So it's 0.1 f, comma 0.1 f. I don't know which way that round it's going to go here. Don't need anything in the last one. Just go in a diagonal turning, swirling kind of motion. Yeah, that's all we need. So, just for testing, we'll do that. Terminal, run build task. Debug. Start debugging. Come on, what's the problem? You can see it, it's right there in front of you, the problem. Where's the terrain? I can't see no terrain here. Using WASD as intended. I can't see no terrain here. Where's the terrain? Well, of course you can't see any terrain. There's two reasons you can't see any of the terrain. One, it's behind us. Two, we're on the same level plane, eye level. We are on the eye level of the plane of the terrain. So we can only see the edge of it, which has no size. So we can't see it. So, first things first, let's sort that out. Okay? Yeah. Okay, I've still got that debug adapter going off. God damn it. I'll have to find that. I think it's probably to do with me being an idiot and I've got something else going on here. Yeah, that'll go. That can definitely go. That's your maths toolbox update. There you go. Now I can close the internet. Thank you. It's interfering. Now I can see OBS, so I can see the sound volumes and everything. That's good. Let's see what else we need then. Let's go back to our camera here. What we'll do with the camera then is take it off the direct plane, which is a flaw. What can we do? We can dot set position, maybe. Might help. It'll be a vector 3 position, so it's just a vec 3, open brackets. So X, we don't want to go across. Y, we want to go up 0.5 meter to eye level-ish. Well, to chin level-ish, 0.5 meter. And forwards and backwards, don't care. Right, so that's that done. Yep, that's right. And it's a vec3. Sorry. Save that out. And now, build it. I'm going on to the debugger this time. I want to see what comes up in here. Yeah, it's working perfectly. There's your graphics driver. Oh, what's this little green thing below us? Oh, did I say it was behind us? Oh, so it is. Oh, wow. Texture hasn't worked very well because we set it up. We actually wrote it in the style of a texture height map, and not really being a textured green thingy. But it's there. It's got the texture on top. It looks green. I don't care that much. Now that grid position there is 0, 0. Watch this. Okay. Pretend you've got an atlas. You've got an atlas of maps. Okay, this is 0, 0 here at the top left. And you decide to put one map there, 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 to grow it. So that map up top left would be at -1 map across and -1 map into the screen. That's the minus direction. Hey, we know all about that. We can do that. So where we're actually doing the terrain, if we ask for atlas position -1, -1, in other words, top left hand corner, or should we say into the screen to the left, guess what happens? There you go. Into the screen and to the left. 0, 0 is now all the way over there. 30 meters away. Somewhere over there. Yeah, it's a long, long way away. And our light isn't very high, so it's not shining as much as it needs to here. But there you go. That's the other end of it. That's 30 meters. Now you know I wanted to scale it down a little touch. That's a long, 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 long way. It shows us that is 2 meters long. Yes, it is, and it's 1 meter down that size, and that's 2 meters, isn't it? It's looking that way. 2 meters by 2 meters. Maybe? I can't remember how we drew it. If it is, it'll look good anyway, no matter what we do. I might have to halve it when I draw it next. Actually, I can show you what happens when we halve it. So, yeah, we need to test that as well, don't we? Scaling. Is scaling dynamic? So if we scale the head back to 0.5, which I think is what I need to do anyway for the game, that's a scaling one. And just run that. Yeah, there you go. It's scaled down. You can see it now looks further away. And that's awesome. Awesome sauce. Everything works, no problems. There we go. Ho hum. We're tested. We're up. We're running. And we're done. I'm going to head off over to Windows now. I'm going to enjoy myself making a game. And then I'm going to show you how to make it. That'll be for the new year, I think. Hoping this video gets up before Christmas Day. If not this weekend, I'll go for Boxing Day if need be, which is Monday. This is 2017, is it? 2018 we're in? I can't remember. There you go, we're on 20th of December now. So that's Thursday the 20th of December. I've got till Monday to get this live. I've got 3 more videos to go up tomorrow, and then I'll do testing. I'll put the whole test sequence up the intro and this video up on Saturday. How about that? Just so you got everything for Christmas, so you can play with it to your heart's content over Christmas. That's my present for 2018 to the world. Thank you, world, for having me. But it's true. I might be an invalid, but I can still do something positive. There we are. Done. We have a test. Yes. Thank you, everybody. Thank you so much for being a part of this. I'm going to say goodbye. I'm going over to Windows. And I'm going to start a game writing tutorial session. Somehow. Enjoy yourselves, peeps. Just remember, it's Christmas. Bear that in mind. It's not just Christmas for yourself, it's Christmas for everybody. Have fun.